Good morning, everyone. Welcome back. One of the first things I wanted to do with you guys this morning is to look at those three problems that you had to play around with over the weekend. We had two problems where you had to simplify the expression using rules of exponents, and then you had to find the missing exponent for that third example. So that's the first thing I want to do with you all this morning. All right, guys, let's take a look. For number 2, we have inside our set of parentheses, we have negative 18, a to the fourth, b to the fifth, all over 6a to the negative first, b to the 0 power. The entire expression is being raised to the second power. So we have a lot going on here. One of the first things we learned to do was to simplify inside the set of parentheses. That's the first thing that's going to be very, very helpful to us. Notice here we have a negative 18 divided by a 6. Again, let's simplify numerator and denominator. If we have negative 18 over 6, we know that that's going to leave us with a negative 3 in the numerator. Notice in our denominator we have an a to the negative first power. We always circle our bases with a negative power, and because this particular a to the negative 1 is in the denominator, we're actually going to move it up to the numerator so that it becomes a positive power. Notice that we have an a to the fourth, so I'm going to write a to the fourth. We move the a to the first to the numerator. We also recall that b to the 0th power, any base to the 0th power is 1 with the exception of 0. So b to the 0 is a 1. So we cross that out and we're going to write 1. Now recall that any number divided by 1 is that number. So dividing by 1 is not going to change it. So I don't have to worry about writing 1 in the denominator. Notice here we have a b to the fifth that's also in our numerator, so we leave that exactly where it is. And notice that there's nothing else left in the denominator because we divided the negative 18 into 6. Okay? The entire expression is being raised to the second power. So I want you to notice the first thing. The first thing is we dealt with what was inside the parentheses, so I'm going to write PEMDAS because that's going to be very important to consider. And then I want to write down some of the rules that we've used so far. So we used the negative exponent rule by bringing the a to the negative 1 up to the numerator and making an a to the positive 1. And we used the zero exponent rule. Okay. Notice we did not use any quotient rule because we actually didn't divide anything. The only pieces we divided were the negative 18 and the 6, and those are my numerical bases, so I didn't actually apply that quotient rule to variable bases. So now let's continue here. Notice we have an a to the fourth and an a to the first. Well, a to the fourth times a to the first is a to the fifth. So that's the next thing. We're going to rewrite this as a negative 3, a to the fifth, b to the fifth raised to the second power. So now we notice that we just use the product rule. Now that everything is simplified inside the set of parentheses, we notice that we're raising the entire expression to the second power. So that implies we're about to use the power rule. Okay. In using the power rule, let's go piece by piece. Inside the set of parentheses, we have a negative squared is a positive. So we know our answer is going to be a positive. Next, every base has a power, and you're going to multiply power times power, power times power, power times power. So this becomes 3 to the second power, a to the 10th power, b to the 10th power. And last but not least, we know that 3 squared is 9. So my final answer is 9, a to the 10th, b to the 10th. And that's it. You're done. Excuse me. Notice the way we flow through this problem. Think about the order of operations, PEMDAS. Sometimes, not all the time, but sometimes it's helpful to take care of what's inside the set of parentheses, especially if you have a fraction inside the set of parentheses and you can simplify. if that's possible, you may want to do that first. Then we move through all of our exponent rules and finally simplified. Notice we took it step by step by step. Be very methodical as you move through these kinds of problems. Let's take a look at number 3. Notice in number 3 we have 6a to the negative fourth, b to the third. The entire quantity is being raised to the negative second power. So personally, what I would do is I would actually write that this 6 has a power of 1. That's the first thing I'm going to do. And actually what I'm going to do instead of bringing the a to the negative fourth to the denominator, I'm just going to distribute the negative 2. So what I'm about to apply here is the power rule. So I'm going to write power rule. And Naz, I'll show you exactly where that negative went as we talk about the negative exponent rule again. So we are going to distribute this in negative 2, so check it out. If I distribute the negative 2, power times power, hence the power rule, that gives us 6 to the negative second power, 1 times the negative 2, a to the positive 8 power, so negative 4 times the negative 2, and b to the negative 6th power, and that's because it's 3 times the negative 2. So far, so good? Now, Naz, you had a point here that was kind of you were wondering about, and that is the base with a negative power. So recall what we learned. Anytime you have a base with a negative power, I want you to circle it. 6 to the negative 2, b to the negative 6. Notice that these are all currently in the numerator. These are in the numerator of a fraction. We learned that all we have to do to ensure that our exponents are positive, to go from negative, is to simply move them from the numerator to the denominator or vice versa, which is exactly what we did here. Notice we brought the a to the negative 1 up to the numerator and it became an a to the positive 1. That's what happens. Essentially, when you move a base from a numerator to a denominator, you're changing that power, meaning you're changing it from positive to negative or negative to positive. So both of these bases with negative powers will move down. Notice that I'm drawing arrows to show that they're moving to the denominator. And then when I rewrite this, a to the 8th is the only base left in the numerator. 6 to the negative 2nd moves down as 6 to the positive 2. And b to the negative 6 moves down as b to the positive 6. Hopefully that helps now. And we're almost done though. We notice a to the 8th, cool. 6 to the 2nd, well, that's 36. And then b to the 6th, cool. So our final answer is going to be a to the 8th over 36 b to the 6th. Okay, so first we use the power rule, then we use the negative exponent rule. So let's take a look at this one really quickly. Naz, you have a question about this. Our base to the negative power is currently in the denominator. So this is, we have an a to the negative 1 in the denominator right now. So when we circle it and move it up to the numerator, that's when it becomes a positive 1. Okay, so if your base is a negative power, you need to move those around, make them positive, and then move forward through the problem. I'm available for tutoring right after this class at 11. Come see me. We'll talk about this more in depth. Now let's look at number 2. You had 4p to the 5th t to the negative 2 all over 12p t to the question mark, and this entire thing was squared. Now I want you to consider something. I want you to consider that the only base we're concerned with is t, correct? So notice here in our denominator we have a t to the question mark. What I could do is move through this problem and show you how the left side becomes the right side, but I also want you really to focus on the fact that you just have to figure out what number goes in place of that question mark so that when you evaluate this entire side, your t to the second power remains in the denominator. So that's an interesting piece here. So what I'm going to do is I'm going to run through this idea of PEMDAS again with you, and then show you how you can progress through this problem and figure out what goes where. Okay, first things first, 4 over 12, well, that reduces to 1 over 3, or simply 3 in the denominator. Notice we have a p to the 5th in the numerator and a p to the 1st in the denominator, so quotient rule says you keep the base, subtract the powers. So p to the 5th over p to the 1st is p to the 4th in my numerator. Next, notice I have t to the negative 2nd power, and I can bring that to the denominator. So that's t to the question mark and t to the 2nd power. Everything inside this set of parentheses is now simplified. So we take this expression and we square it, because that's exactly what we have here. And then I want to take it a step further and see what's happening. Okay, so here we have a distribution problem. Let's distribute to each piece. Distribute, distribute. We have p to the 8th power over 3 to the 2nd power, which is 9. And then we have t to the question mark, so let's call that t to the 2 times question mark. And then we have t, to the 4th power. Now remember, and by the way, this is a typo. That should be p to the 8th. I apologize about that. Recall that we want t to be the 2nd power, to the 2nd power in the denominator, but check out what we have here. We have a t to the 4th, and we have a t to the 2 times something, right? But if we have 4 t's in the denominator, that's way too many, right? We only want to have 2 of them. So if you think about it, if you only want to have 2 t's in the denominator, shouldn't you take 2 t's away by placing a t to the 2nd power in the numerator? If we think about it like this and we say, let's make the question mark equal to a -1, check out what happens. We have p to the 8th over 9 t to the -2, right? Because 2 times a -1 is -2, t to the 4th. Anytime you have a base with a negative power, you're going to move that from its location to either the numerator or denominator, whichever is opposite. That gives us p to the 8th, t to the 2nd power, all over 9 t to the 4th. And now, quotient rule. Keep the base, subtract the powers. If you keep the base and subtract the powers, you're going to be left with p to the 8th over 9 t to the 2nd power. So your question mark in this case was equal to -1. That's definitely a little bit tricky. But luckily, you won't really see too many of these, but I don't want you to kind of steer clear of these problems simply because of that. I want you to continue to play around with the rules of exponents and understand how these bases move or how these bases are impacted depending on the rule. And Naz, real quick point, up here for number 2, that's not a negative exponent. This is a -3. So if this -3 were being raised to a negative exponent, then you would apply the negative exponent rule. But this is just a -3, okay? Negative exponents are very different from a negative quantity. So keep that in mind. All right, excellent. So we covered those 3 homework problems that I wanted you to try out on your own and see how they went. So let's continue with where we left off. Last Thursday, we talked about multiplying polynomials. Notice for number 7, 4m minus 7 raised to the 2nd power, we actually had to expand that. We had to write it twice before we actually distributed. We also talked about the fact that if we had 4m minus 7 quantity raised to the 3rd power, you would actually expand it 3 times, and then you would distribute. What I may do if we have time at the end of this is I can show you what you would do or what it would look like if you were to expand it 3 times and how you would go about multiplying. It's the exact same strategy, but you just end up having to do 2 steps. And that's okay, I'll show you. But either way, once we expanded, we distributed. We started with our first term. We distributed to everything that's in the second set of parentheses. And then we moved to our next term, and we distributed to everything in the second set of parentheses. So the idea here is you just have to distribute, correct? Just like we used to in Unit 2, except this time it's a little bit more involved because we have a binomial times a binomial. Now, having said all of that, take a look at our next problem, number 1. These are considered challenge problems. So let's take a look at these 3. So the first one, we have 2n plus 3, binomial, times n squared minus 4n plus 1, trinomial. Now, I want you to consider that all we're going to do is apply what we learned, which is if we are multiplying polynomials, all we have to do is distribute. So I'm going to start with my 2n, that's my first term, and I'm going to distribute to everything that's in the second set of parentheses. Before we continue, I also want you to note that a binomial, 2 terms, times a trinomial, 3 terms, so we have 2 terms times 3 terms, that should leave us with 6 terms. And we're going to prove that. Obviously, that would be before we simplify by combining like terms. So let's check it out and see what happens. So we have 2n times n squared. That's going to give us 2n to the third power. Remember, keep the base, add the powers. This is a 1. 1 plus 2 is 3. Also, think about the way it sounds. 2n to the first times n to the second. Well, you have 3 of them all together, 2n to the third. Next, we have 2n times negative 4n. So 2 times negative 4 is a negative 8, but n times n, remember, n times n, you hear that there are 2 of them. So this is n squared. And last, for this term, we have 2n times a positive 1, and that's simply a positive 2n. So far, so good. Now that we have distributed the 2n to everything in the second set of parentheses, now let's distribute the 3. Same exact idea. 3 times n squared is 3n squared. 3 times a negative 4n is negative 12n. 3 times a positive 1 is positive 3. Excellent. Take a second. Take a look at how many terms we have. 1, 2, 3, 4, 5, and 6. So we expected that when we multiplied a binomial with a trinomial that we would have 6 terms, and that's exactly correct. At this point, we're now at the beginning of this unit where we were adding or subtracting polynomials, right? That just means we're going to combine like terms. So notice my largest term is a 2n to the third. I'm going to write that first. My pair of like terms is a negative 8n squared and a positive 3n squared. When we combine these, we'll get a negative 5n squared. Next, we have a positive 2n and a negative 12n. If we combine these two, that gives us a negative 10n. And last but not least, we have a positive 3. We're not going to just erase the constant because it doesn't have a pair or a like term. We're simply going to bring it down. And there is your final answer. 2n to the third minus 5n squared minus 10n plus 3. Done. Excellent. Hopefully that wasn't too terrible. I hope that you're looking at this and you're actually enjoying this opportunity to kind of play around with these problems. Let's take a look at number 2. This is our second challenge problem. Notice what we have here. Okay, there's a couple things going on. First off, 8n plus 3, all of this raised to the second power. That's very, very important that we recognize that we are going back to this idea of when we have a polynomial being raised to a power, we have to expand it that many times, right? Because this is not a monomial. If it were simply 8n to the second power, well, fine, that's 64n squared. But what's happening here is we have a binomial raised to the second power. So what that means is we have to expand it. We have to rewrite first. So what I like doing for problems like this is I like doing some side work. I like doing side work so that it doesn't clutter all of my workspace here. So what I would do if I were you is I would take the 8n plus 3, and I notice that 8n plus 3 squared gets rewritten twice, and then you essentially distribute. I would do that first. Okay, let's take care of this expression. We'll take care of multiplying these two together, and then we'll write that underneath here in our workspace. Okay, so this is like our side work area. 8n times 8n is 64n squared. 8n times 3 is 24n. 3 times 8n is 24n. And 3 times 3 is 9. Excellent. So far, so good. Notice we have like terms. So we want to bring these like terms together. So that's 64n to the second plus 48n plus 9. Excellent. This expression right here will replace the 8n plus 3 squared because essentially we have evaluated this. So I can write on this side 64n to the second power plus 48n plus 9. The next thing we notice is that we have 8n plus 3 quantity squared minus a trinomial. So minus 7n squared minus 11n minus 1. When we first started these notes, recall that when we were subtracting polynomials, we distributed that negative through everything that came after it. So essentially, you distribute the negative throughout the set of parentheses that immediately follows it. So, having said that, I'm going to distribute that negative. Think of it as distributing a negative 1 if you find that to be helpful. A negative times 7n squared is a negative 7n squared. A negative times a negative 11n is a positive 11n. And a negative times a negative 1 is a positive 1. I want you all to notice that as I move through the problem, I'm being very vocal about what my operations are. I'm stating out loud what I'm doing here. So like for instance, a negative times 7n squared. A negative times a negative 11n. A negative times a negative 1. If you're more vocal about it, chances are you'll be able to kind of hear the operations so that you can simplify them and make sure that what you're writing matches what you're thinking. Okay? Next, we are going to combine the like terms. We have a 64n to the second power, and we have a negative 7n to the second power. So these are my like terms. We're going to take 64 minus 7, and that gives me 57n to the second power. There's our first term. Next, notice we have a positive 48n and a positive 11n. When we combine these, we get a positive 59n. And then last but not least, we have a positive 9 and a positive 1. So combine these two together gives us a positive 10. And that is your answer. Notice that we use some strategies for success. We took the work for 8n plus 3 to the second power. We did this on the side so that we didn't clutter our work area or our answer area. And then we distributed that negative throughout the second set of parentheses, and then we combine like terms. When you play around with these in Lumen, I think you're going to find them to be very straightforward, especially if you're understanding what we're doing right now. Okay, let's turn the page. Okay, one more. 3x minus 11, the entire thing raised to the second power, minus 2 times 13x to the second minus 6x plus 5. I'm going to give you just 2 minutes to do your work for this problem. Let's see what you come up with. As soon as you're done, go ahead and type in your answer into the live chat. Let's start the 2 minutes now. Okay, let's take a look and see what you guys had for number 3. We've got some answers coming in. Let's take a look. First things first, 3x minus 11, quantity raised to the second power. Again, I'm going to do some side work just to keep everything nice and neat. So we know that that is 3x minus 11 times 3x minus 11. So we're going to distribute here and see what we get. So I'm going to draw the lines of distribution. 3x times 3x is 9x squared. 3x times a negative 11 is a negative 33x. Negative 11 times 3x is negative 33x. And negative 11 times a negative 11 is positive 121. Okay, so far so good. Notice these two are like terms, so I'm going to combine them real quick. So we have 9x squared. These are not opposites, so they do not cancel each other out. Be super careful with that. And negative 33 and another negative 33 is a negative 66x. And then finally, plus the 121. We're going to bring this expression right underneath what we evaluated. So we have 9x squared minus 66x plus 121. Notice for our second set of parentheses, we have a minus 2 times 13x squared minus 6x plus 5. What this implies is that we are going to distribute the negative 2 in order to drop parentheses. So we have, and again, let's draw the lines of distribution. And again, it's helpful to say everything aloud. So negative 2 times 13x to the second power is a negative 26x to the second. Negative 2 times a negative 6x is a positive 12x, and a negative 2 times a positive 5 is a negative 10. Excellent. Now that everything has been expanded, we are going to combine like terms. So my first pair of like terms is a 9x and a negative 26x squared. When you combine a 9x with a negative 26x squared, you'll get a negative 17x squared. Bethany, yours is looking better so far. Josh, a nice attempt at this. Then we have a negative 66x plus 12x, so we're going to combine these two. So we have a negative 66 plus 12, well, that's going to give us a negative 54x. And last but not least, we have a positive 121 and a negative 10. When we combine these two, we get a positive 111. Wow, the combination of your answers is perfect. Excellent job, guys. A nice effort on this problem. Be very careful with all of your signs and make sure that you're keeping track of them as you move through these problems, and then you're going to be just fine. I love it. That was awesome. Haha, Josh, I see that. Very cool. Okay, so let's move into our last section for Unit 6, and that is division of polynomials. This is actually a very small section because, I'm actually going to come to me. This is a very small section for us because all we're doing in this particular class is we are taking a polynomial and we're dividing it by a monomial. When you guys move into Math 104, then you'll be dividing polynomials. So you'll take a trinomial or whatever, you'll divide it by a binomial, and then you'll look at methods like long division or synthetic division. So for right now in this class, the only thing we're going to be looking at is simply put taking a polynomial and dividing it by a monomial. So think about it as like, for instance, let's say we had a trinomial, right? 3 terms. And we want to divide it by a monomial, which is 1 term. So think about 3 divided by 1. Well, isn't 3 divided by 1 3? It's still 3. So even though we are taking this polynomial and dividing it by a monomial, we will still have the same number of terms as what's represented in our numerator. Hopefully you'll be able to see that, and hopefully that makes sense considering everything we've done with multiplication so far. Okay? Let's take a look at division of polynomials, and like I said, that concludes Unit 6. Check it out. Notice here what I've written in bold. rewrite, then reduce. When we are taking our polynomial and dividing by a monomial, I urge you, please, 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 rewrite it, then reduce. So let's take a look. Notice we have 35x to the second minus 10x. This is a binomial, right? We have a binomial over a monomial. So we should have two terms. So my first term is 35x to the second over negative 5x. And then we have a minus 10x over negative 5x. Do you see how all I did was I split them up into two terms, both of them being divided by a negative 5x? If you think back to what we did, and I want to just do a quick recall. If you think back to when we would take our y in something like, let's do 4x plus 5. Let's say that we wanted to get y by itself because we wanted to write our equation in slope-intercept form, right? Recall this from Unit 4. If I wanted to solve for y in this case and rewrite it in slope-intercept form, I would have to divide each term by 2, right? That's exactly what we're doing here. We're rewriting it so that we're showing that each term is being divided by that denominator, which is exactly what we used to do when we would try to rewrite our equation in slope-intercept form. So for instance, this would become y is equal to 2x, because 4 over 2 is 2, plus, and then 5 over 2 doesn't reduce, so we leave it 5 over 2. What I want you to notice is that 4 divided by 2 became 2. So you reduced it, didn't you? You took advantage of that and you said, I'm going to simplify my fractions whenever I can. And you did exactly that. So what's happening with division of polynomials is the exact same idea. We are going to separate the terms so that it's each term in the numerator being divided by the monomial in the denominator, and then we reduce. So let's take a look. Notice we have a 35 over a 5. 35 divided by 5 is 7, so 7 would be left up top. Also notice, don't you see it's a positive divided by a negative? So because this is a positive divided by a negative, we know our fraction, our first term is going to be negative. 5 goes into 35 7 times. And then we have an x squared over an x to the first power, quotient rule. Keep the base, subtract the power. So x to the second power over x to the first leaves us with an x to the first in the numerator. And that takes care of my first term. I prefer not to cross things out here because it gets so messy and I want you guys to see what's happening. So if that means you have to rewatch the video and just kind of listen through the process again, that's okay. This will be available for you as soon as we close out the live stream today. Next, we have a negative, so it's minus divided by a negative. A negative divided by a negative is a positive. So right away, I'm going to simplify. Next, notice 10 divided by 5 is 2. And then notice x divided by x, these cancel. If these cancel completely, you do not have an x left over. It wouldn't make sense to have an x left over. In our first term, when we had x squared over x, sure, that left us with one of them. But here, because it was x to the first over x to the first, those cancel each other out. Much like it would if you had something like 7 divided by 7. Wouldn't 7 divided by 7 just be a 1? Okay. Once we've reduced each term, we're done. That's all we have to do. We just have to simplify. All right. Let's take a look at number 1. Perform the indicated operation. The indicated operation in this case is definitely and clearly division. So what I'd like us to do is rewrite, then reduce. So we're going to rewrite as negative 14m to the 8th over 7m to the 3rd. Positive 7m to the 3rd over 7m to the 3rd. Minus 21m over 7m to the 3rd. Do you see how every term is being divided by the monomial? 3 terms divided by 1 term. 3 divided by 1 is 3. So we should be left with 3 terms after we simplify. Let's take a look. Negative 14 over 7, that reduces to negative 2. That negative 2 is in the numerator. M to the 8th over m to the 3rd. Keep the base, subtract the powers. 8 minus 3 is 5. So it becomes m to the 5th. So our first term is done. Negative 2m to the 5th. Done. Let's take a look at our second term. 7 divided by 7, well, that's a 1. M to the 3rd divided by m to the 3rd, well, that's a 1. And 1 times 1 is 1. For our last term, notice 21 divided by 7 is 3, so the 3 is left on top. And then notice it's m to the 1st in the numerator and m to the 3rd in the denominator. So because we have more m's in the denominator than the numerator, 3 minus 1 is 2, and you're left with m squared in the denominator. And that's your answer. You're done. You just have to rewrite, then reduce. Let's do it again. Number 2, we have 9x to the 3rd minus 15x squared plus 7x minus 11. All of this being divided by a negative 21x squared. If you are following my strategy, you're going to do great. Okay, guys? All you have to do is rewrite it. 9x to the 3rd over negative 21x squared minus 15x squared over negative 21x squared plus 7x over negative 21x squared minus 11 over negative 21x squared. Not bad. Now we go term by term. Okay. With our first term, we have a 9 over a 21. We definitely know that we can't divide these as is, but we can simplify, meaning 9 and 21 both have a common factor of 3. So 9 divided by 3 is 3. 21 divided by 3 is 7. Also notice a positive divided by a negative is a negative. And then notice x to the 3rd over x to the 2nd power. Well, these are the same base. So that means we are going to apply the quotient rule. You keep the base, subtract the powers. So x to the 1st power will be left in the numerator. And there's your first term. Done. For my second term, a negative divided by a negative is a positive. Let's take a look at the 15 and the 21. Same thing. Notice that they're both divisible by 3. 3 goes into 15 5 times. 3 goes into 21 7 times. Notice x squared divided by x squared. Well, those are going to cancel, and it leaves us with simply a 1. So 5 times 1 is 5. That takes care of my second term. Next, positive divided by a negative is a negative. 7 over 21, let's reduce again. 7 goes into itself once, and 7 goes into 21 3 times. So notice, if you want, you could put a 1 here and a 3 in the denominator. 7 into itself once, 7 into 21 3 times. Next, we have x over x to the 2nd power. Again, if it's helpful, write that as an x to the 1st. X to the 1st over x squared. Quotient rule. Keep the base, subtract the powers. You're going to be left with x to the 1st in the denominator. It's heavier down there. And last term, we have a negative divided by a negative is a positive. We have an 11 over a 21. Now, unfortunately, they do not have any common factors, so we can't simplify that piece, and that's okay. And then notice there's no x to cancel this x term out, or this x base, so all we have to do is leave it exactly where it is. And that, ladies and gentlemen, is the final answer. I know it looks crazy. I know it looks super messy, but you should feel like this ended up going pretty well, considering we had a 4-term polynomial divided by a 1-term polynomial. 4 divided by 1 is 4, and we had 1, 2, 3, 4 terms, which means, okay, that's probably a successful outcome. And then we carefully went through each one and we simplified everything that we can do. Okay, because we have 4 more minutes, I'm actually going to simply rewrite number 3, and then I want you to try this. What I will do is I'll scan the notes and I'll send them to you via email, so that way when you see my answer for number 3, you can check it with yours and see how you did. So first things first, let's rewrite this. Negative 4m to the 4th n squared, that's my first term. That entire expression is my first term. That is divided by negative m to the 8th n. My second term is a negative 11m to the 3rd n. And this is being divided by negative 8m to the 8th n. My third term is positive 15m squared. And that's being divided by negative m to the 8th n. And last term is minus 13, and that is also being divided by negative m to the 8th n. So now that I have this problem rewritten for you, I would like you guys on your own to finish this, and then don't worry about emailing me your answer. I will send you my answer key. I'll send you the guided notes filled in, and you can see how you did. All right, guys? Stay safe, stay healthy, stay at home, be productive, make sure you're doing your homework. All right? See you guys.